simplify radicals? Well, there's a few different ways to go about it, but let's talk about just simplifying something basic, like square root of 9. Well, you know what the square root of 9 is. The square root of 9 is just 3, but here's why. When we are looking for a square root, what we're looking for is a number that we can raise to the power of 2 to get 9. So I'm looking for what number can I square to get 9? Well, the number that I'm looking for is 3. So something that we can do is we can factor your 9 down and just look for groups of 2. So if I were to redo this, I could take my 9, factor it, and look for numbers that make groups of 2. Well, here's a group of 2. That means that I could raise that to the power of 2 to get my original number. So I can go ahead and take it out of my radical. So this would become just 3. So this pair of 3's comes out of the radical as a single 3. That's the process I'm going to use on the next couple examples. So let's simplify these two. First thing I'm going to do is take my 63 and factor it. This is a square root, so I'm going to look for things that pair up in groups of 2. When I factor my 63, I have 9 times 7, and then that 9 breaks down into 3 times 3. So I do have a pair of 3's, and just like in the last example, a pair of 3's means that it gets to come out of the radical as a single 3. But anything that doesn't pair up just has to stay inside. So the 3 gets to come out of the radical, but then underneath the radical, I still have that 7 that didn't pair up with anything. So square root of 63 simplifies into 3 square root of 7. Another way that this is taught is to factor out the perfect squares. So you could also say that square root of 63 is equal to the square root of 9 times 7. And then I can break apart my radical into the square root of 9 times the square root of 7. Square root of 9 we know is 3, so that would just be 3 times the square root of 7. The reason I'm not so fond of this method is that as you start dealing with larger numbers, it gets harder to identify the perfect squares within each of those numbers. But if you're comfortable with your perfect squares, this is a great method to use. So the next one, this one for example, I don't know off the top of my head what perfect squares I could pull out to simplify. So what I'm going to do is just start factoring. I know it's an even number, so I know I can divide by 2, which gives me 1,323. Now I know that that 1,323 can be divided by 3, which leaves me with 441. I can divide by 3 again, and again, and now I divide by 7s. So I see a couple different things that pair up. I see a group of 7s and a group of 3's. So that tells me that I can pull out a 7 and a 3 from my radical. When you pull out more than one thing, we just multiply. So 7 times 3 is going to be on the outside. So 7 from that first group, 3 from that second group, and then on the inside of my radical, I have the remaining 2 and the remaining 3. And again, I just multiply. So my final radical is going to be 21 times the square root of 6. Okay, let's do a couple more. So now we've got some negatives underneath. The square root of -1, we just define that as I. So this is just going to be called I. Anytime you have a negative underneath a square root, we can go ahead and pull that out of the radical and it becomes I. So for example, -36 underneath that radical, I see a negative, so I could pull that out of the radical, and now the 36 underneath the radical is positive. So I just took that negative and said, I know what the square root of a negative is, it's I. So now it's on the outside. I can go one step further. I know what the square root of 36 is. If you need to make pairs, you can. If you're comfortable, you don't have to. Square root of 36 is just 6, so this is I times just 6, which becomes 6I. Okay, I've got 2 more for you. So I'm going to do the same thing, except your radicals in these aren't going to simplify all the way. So negative 20. First thing I see is that I can pull out an I because I do see that negative underneath the radical. Then I factor my 20. And I see a pair of 2's and a 5 that will have to stay inside. So the 2 gets to come out. I multiply it by the I that's already there. So this 2 just got to come out in front of the I. And then what's inside the radical is that 5. So that square root 5 still stays. So this simplifies to 2I square root 5. In the second one, I still see another negative, so I'll pull that out. And then I have square root of 600. I know that 600 is 6 times 100. So to make it easy, I'll start with that, and then I'll break my 100 down into 10 times 10. My 6 is going to be 2 times 3. So I have a pair of 10s. I can go ahead and pair up the 10s, and then the 10 is going to multiply on the front, in front of that I. So I have 10I, but then inside the radical, I still have the 2 and the 3 that didn't pair up. So 2 times 3. So 10I square root 6. So these were a couple examples of how to simplify square roots. I hope that helped. Thanks for watching, and I'll see you next time. Bye.